So we, up to this point in lesson 6.2, what we've been doing is evaluating. We can actually get a value and say, okay, this is what it's equal to. Whether it was a fraction answer, something between 0 and 1, or it was a number greater than 1, or whatever it turned out to be. Today we're not going to be able to do that. So we are looking for the 5th root of x to the 5th power. Anybody know what it is? The 5th root of x to the 5th power. That's really what this is asking for. Okay, tell me what you did in your papers then. What's your attempt at this? What's your attempt at it? Cody, what's your attempt?
I put x to the 5th power in parentheses and put a 1 over 5, 1/5, well, on the outside of parentheses.
Okay, so let me see if I'm understanding what I think you're trying to tell me. You did this.
Yes.
And you put a 1/5 on the outside. Is
Yes.
that 1/5 an exponent?
Yes.
Okay. Or a multiplier. Which one? It's an exponent? Okay. So anybody else do it this way? This is how you started? Okay, Cody, explain to them why you started this way. What's the reason?
Because I don't have a variable or a thing for x. So I just put x to the 5th power to 1/5, and then
So don't tell me any more from where you went from there. I just want to, why could we write it like this? Why justify why we could write it x to the 5th power to the 1/5 power? You're right, we don't know what x is, so we can't really evaluate it. Okay, let's hear some other ways that other people started this problem then. What'd you do? Okay, Aurora, you talk to Abby and Faith. Julia, you talk to Michaela and Tori. You two turn around and talk to these two dudes and let's see what everybody else did this. Let's find out. Because you don't want to talk to me, so turn around, take your papers, turn your chairs, tops.
Julio.
Because apparently nobody else did it Cody's way. So Cody, what'd they do?
Huh?
Make sure that they did something different than you because they don't want to own up to your way. Okay. If you're not willing to share your way, then you have to share somebody that you just shared with way. You have to, give away theirs then. Okay, so somebody tell me another way that this got done.
No one's got a different way.
He does, okay. Noah, how did you do it?
I took 5 divided by 5 and I got 1 and I used that as the exponent.
As the exponent of what?
X to the 1 power and then
Okay.
for my answer I just got x.
Okay, justify for me how you can do 5 divided by 5. Why can you do that?
Because there was a 5 x to the 5th power and it was taken by the square root of 5 on the outside.
So we have some sort of a property that says, we have a shortcut, we have a property that says you can take the exponent that's in the radicand and you can divide it by the index that's, that little number in the crook of the radical sign. We have some sort of a property that said we could take that and we could divide. Could you find that in the notes for me, please? Where's that property that says we can take the exponent on the radicand, the base, we can take the exponent on that one and we can divide it by the index and we will have the exponent on our simplified answer. Then in our notes. Maybe we've got a new property we discovered here then.
No, it's not.
It's not in there? Huh. I wonder if we could use this. Is this a new property we could use? I wonder. We'll find out. Anybody else try that? No? Okay. Okay, let's hear another way then. Because so far I got Cody, nobody says they did it his way. So that's only one person there. And then there's Noah, this is how he did it. None of you said you did it that way. So that's 2 people we're up to now. And so we got, 10 people in here today. There's 8 other people who had to have done something else. Cody, you can't offer up another one. Or do you want to offer up Calvin's? Oh, okay. No, nothing else. If all else fails, you can offer up other people. Calvin, what do you do?
I do the same thing as Cody.
Really?
Yeah, I had no clue what to do.
Oh, so you just decided just to go with his. You didn't hadn't done anything.
I was guessing.
You're guessing. Well, that's what we're all doing right now. We're guessing right now. Yeah. So was that your guess to start with?
Yep.
Oh, then when I asked you if anybody else did a coding, how come you didn't offer up? Happy,
Same
happy,
answer.
happy, 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 happy.
Yeah.
About what? Algebra?
I got on the corn off pretty quick.
Good. Yeah. Awesome. Did it yield well?
Yeah, it was good stuff.
Whew. Okay. Christmas presents from Calvin for all of us this year. Nice.
Hooray!
Hooray is right. Okay, Faith.
Well, I think it's wrong, but
That's what we're doing. We're guessing right now.
I did x to the 5th over 5.
So x to the 5th, like this, and then over 5, like this?
Yeah.
Okay. So this is your start. Okay, anybody else start it this way like Faith did? Because we're all just trying stuff. We just don't know what we can really do or not do at this point. Okay, so now we're up to, well, I guess we can say 4 because Calvin stole Cody's. Devontae, you have a different one too? Cody's just picking on all of you in this group.
Where? What?
What did you do?
I have some of Cody's.
You did the same thing as Cody? So you stole from him too?
I'm gonna have to put a, what is it called,
I would put a barricade around your little
no, I'm gonna have to put a, what is it, a patent on my stuff.
Oh, you're gonna have to patent your work, man.
Yeah.
Okay.
Then I can see these two.
Okay, well, I haven't heard of anything from this row here. What do you guys do?
I did x times x times x times x. Like x and itself 5 times equals x in parentheses.
So this goes in parentheses?
No.
Okay.
After that equals x in parentheses to the 5th.
Is that 5th in the parentheses or out? Outside the parentheses, okay.
And then equals x.
So then now you're saying the answer for this is x to the 5th.
Yeah.
Okay. Anybody else do it? Julia's one?
I think I get what you're trying to ask us for this one. I think I get what it is.
Okay.
Going up with Julia's.
Okay.
So wouldn't it be x to with parentheses to the 1/5 power? Because you still have the 1/5 from your square.
So each of these x's should have a 1/5 power on it, you're saying?
No, just the last one. Because you're still taking. Okay, so can I just go up there and put it on the whiteboard?
Sure.
It's a lot easier to just show. Okay, so taking it from what Kayla did, or what from what Julie did,
Wherever you are.
x equals x parentheses over 5th power. Because you still have the 1/5 from your square rooting right here.
Don't you dare get that blue marker on my smartboard.
Here, put the cap on. So you still have this 1/5 here. So once you got rid of that from this, because you don't have your parentheses here, so in the order of operations, exponents would come next. You get x, and then you'd have the square root or the 5th, or however you say it, root of x. So then you'd have over here. Then you'd get your x to your 1/5.
So you think then we're going to say the answer is x to the 1/5 power then according to that?
Yes.
But Julia says it's x to the 5th. Don't be trying to change her mind. Okay, thank you. Do we agree that x times x times x times x times x is x to the 1/5 power? What would it be? Well, just a minute, no. What would it be? 5th, because we're taking powers times each other, so 1 plus 1 plus 1 plus 1 plus 1, is that 1/5? So I don't think we can agree with this part, Cody, that it's x to the 1/5. I think you know what you're trying to say, but that isn't really what's working, what's going on here, Faith.
Don't you have to divide x by 5 and then that answer you take to the
Take x and divide it by 5, and then that answer you would take to the 5th power.
because that's what you do with the numbers.
So, but if we don't know what x is, can we really legitimately figure out what x divided by 5 is? Okay, and then so we would have x divided, we would have x divided by 5, and then you said, can we,
X 5 times.
What, pardon?
What goes in X?
What goes into X 5 times, okay? So X divided by 5, what goes, how many, yeah, no, you know what, I think what I need to show you is this, and we're gonna keep going with Julia's here, and we're gonna say, you know what, this is what's really under the radical sign, this right here. Isn't that what's under the radical sign? X to the 5th means X times X times X times X times X. And then, but then there's still this little 5 out here, right? And what does that little 5 say? The 5th root of this stuff. And that means what time, 5th root means what times itself
Equals X.
5 times equals that. So that X times X times X times X times X, or that X to the 5th, it's really asking you what times itself 5 times gives you this. Well, we can clearly see what's happening. 1, 2, 3, 4, 5. X times itself 5 times
Equals X to the 5th.
is X to the 5th. So we are finding that, you know what, that X is really the 5th root. So instead of saying here that we have this X to the 5th, we would have just X, wouldn't we? Okay, and then, so that's kind of what ends up happening over here. Noah said, when I did this, I ended up with just X, right? Remember she said no? And then Cody, I wouldn't let him keep talking, right? I kind of stopped you and said, let's not finish that yet. Would this right here give us just X? Would this right here give us X? No, it probably wouldn't get us there, would it? Okay, so let's get rid of that for a second. Okay, so now let's go further with Cody's then here and see what really happens. So you know what, this is kind of like, we usually typically start with it like this, and then we move to writing it as its radical. Isn't that typically how we do it? Now it's starting as a radical, and we're undoing it. We're writing it as a power to a power. So this is X to the 5th power,
Which would be X.
which needs the 5th root, which is the same as taking it to the 1/5 power. If you have to find the root of something, it becomes the denominator of a fraction. So what do we do when we have a power to a power? What's our property for that?
Parentheses before exponents.
No. What do we do when we take a power to a power?
We
Multiply
add-
the exponents. Multiply the exponents. Multiply that 5 times that
Do you
1/5.
change the 5 over to 5 over 1?
Put that in over
And then you
1.
get 5 over 5. you
Why,
get X to
looky
the
there,
fifth
we get X to the 5 over 5 power.
Which is equal.
Oh, which is 5 divided by
5.
5, which is then X to the
First power, which equals
first
X.
power, which really is X. Okay, so right now it's kind of looking like Noah's shortcut works, right? But it's got to work lots of times before we can use it. So we're going to go with the actual way we're going here. So I'm going to erase everything else, and this is what should be in this problem right now, okay? There you go. That's number 1. We first take it and we write it as a power to a power. Rename it as its power to a power name. Then we apply the property that says when you have a power being taken to a power, you multiply its exponents. And then if you can simplify that exponent, you simplify it. And the final answer for this, oopsie, and the final answer for this one should be X. So again, remember this says, what times itself 5 times gives you X to the 5th? What times itself 5 times gives you X to the 5th? Does X times X times X times X times X give us X to
Yes.
the 5th? Absolutely it does, yeah. Okay, so now I want you to take number 2. We'll explore Noah's, can we take a shortcut thing here? After we're done with all 4 of these, we'll see if it works for all 4 of them, okay? So let's do the power to a power name. What's the power to a power name for number 2?
Number 2.
Number 2's power to a power name. That's all I want right now. Noah?
A to the power of 8. And then in
I got it.
parentheses to the 1/5. parentheses time to the power of 1/2.
Okay. Cody?
To make it easier for with Noah's, wouldn't you just be able to put a to the eighth times b to the second to the 1/2 power?
Yeah. It could really start out, first of all, like a to the eighth, b to the second, the base, the radicand. Even though it's a product, we could still call it a base, we can still call it a radicand. When there's not an index number there, what's our invisible index number? No?
2.
2. Second, you're looking for the square root. So that means we're taking it to the 1/2 power. And then what Noah did is he would jump straight to the next step that says, okay, here's what's going on, folks. You have a product inside those parentheses. You have a to the eighth times b to the second. So you have a product to a power. What's the property for a product to a power? What do you do when you have a product? You give each one its own exponent. So now we have a to the eighth. It gets its own exponent of 1/2. B to the second gets its own exponent of 1/2. And now we have a power to a power. What do?
You
Multiply the exponents. Yep, I'm seeing Abby kind of mouth it, whisper it over there. And then same thing here, right? A power to a power. So we'll take our 2 and we'll multiply it times 1/2. Okay, what's half of 8? 4. So this becomes a to the 4th. And what is half of 2? 1, so that becomes b to the 1st. And that cleans up to what?
to be
A, B, 5.
A to the 4th, b. Okay, let's just, let's check Noah's shortcut. Noah's shortcut would say what, Noah? What would you do in your shortcut?
Divide 8 by 2 and 2 by 2.
Okay, because there's an invisible 2 out here, is that why?
Yeah.
Okay, so you would take 8 and divide it by 2, and you would say, oh, that's going to be 4, that's going to be my exponent on the a, right?
Yeah.
And if I take 2 and divide it by 2, that's 1, and that's going to be the exponent on the b. So we would have a to the 4th, b to the 1st, a to the 4th, b. It's worked twice now. Okay.
Is there a name for the property? The property that Noah just did?
That Noah's just doing that, his new shortcut?
Yeah.
Not really. It's kind of like this is just finding the root,
But
property.
there could be a property name.
Should we call it Noah's property?
Noah's estate property.
Noah's lucky property?
Yes.
There you go. Okay. Go ahead, try number 3 on your own now. You got this.
I have a question.
Yes, Cody.
When you get to where you have x to the 9 times 1/3.
So this step right here.
Yeah, and when you have, can we just like skip to put them in parentheses or put them into the first unit of fractions like 9/1? Can we just like skip to that?
Yep.
And then we could like cross multiply. 3 goes into 3 once, 3 goes into 9 3 times, and then 3 goes into 3 once. And
Or 3 times 1 is
No.
3. Now you have a 3 times 1 upstairs. You have just that 1 downstairs.
And then you have the 12 and the 3, which is 4.
Mhm.
So it's like Noah's, but it's a little shortcut, so that it's fast, like right before it gets, well, it's saving more steps.
Makes sense. Okay, everybody get this answer? Anybody need to correct me? Okay, let's see if Noah's lucky property still works. If you want to use Noah's lucky property, you would show what kind of work instead?
Division.
Okay, so what's the first division problem going to be?
9 divided by 3.
9 divided by 3, and that equals 3. So you would say that's what x is going to be, right? So the third power. Okay, and then what was the next one?
3 divided by 3.
3 divided by 3, and that is 1. So that's what's going to be the exponent on the y's. And then
12 divided by 3.
12 divided by 3, and that is
4.
4. So that's going to be the exponent on z. And then you bring them all together, and let's see if we get the same. Y to the first can I rewrite as y?
Yep.
Okay, and z to the fourth. Do we get the same answer?
Yes.
It's worked 3 times. If it works one more time, you get to use this shortcut. But you gotta show, that worked then, right? Can't just have the answer, you gotta show either the red or the blue. Yeah, exactly. Okay. Questions? Here's where it's gonna get trickier. When there's numbers in there and not just variables. Now, we'll know what's lucky property work. Okay? So let's try the other way first. How would we write this as a power to a power? Devontae, how would I write that as a power to a power?
16. So 1/4 power. Yeah, in parentheses.
So 16m.
Oh, your name isn't Devontae.
Can you pass it on?
Devontae, could you, I only want to hear from you, so could you help me out again? Try. What were you doing?
16 to the 1/4 power. Oh, times m. So
This is Devontae. What part of this don't you guys get over there?
Or given minutes.
No, he doesn't need hints.
He's his own man.
He's his own man, is right. Okay? Devontae? Back to me.
times m to the 8th power. Oh, in parentheses. No, wait, the whole thing in parentheses. I'm not sure.
Okay, first of all, this is not a power to a power, this is a product of powers to powers. So you know what? I'm going back, and I'm going to ask for somebody else to give it as a power to a power. That's how I want it. Okay? I don't want any steps skipped. I just want a power to a power. Okay? Oof. Goodness sakes. Abby, do you think you can help us out?
16 m to the 8th in parentheses and then to the 4th.
Good job. There we go. That's a power to a power. The index becomes the denominator of a fractional power, and what was underneath the radical sign becomes our base in our power. So now we are going to do what, Devontae? What do you think I'm going to do now? I'm going to give you another chance here. You maybe don't want that chance. What do you want to pass it to?
Noah.
Okay, Noah.
Wait, no, Cody.
No.
You put your name.
Don't expect him to invite you to your. Okay, Noah. What?
Tables will turn now.
Help.
Would we divide this?
We're trying to use your property.
Dang it.
Julia?
16 and to the 8. And then
Faith?
you take the 8 divided by 4, so it'd be 16 and to the
Okay, but wait a minute, we can't use any shortcut dividing things here yet because we're still making sure we can do it the right way. Like the properties we know we can count on right now. So Michaela?
Don't you give 1/4 to each property?
Okay, each factor.
Yeah.
Okay, so what?
16 to the 1/4, and then m to the 8 in parentheses to the 1/4.
There we go. We give each of them. We have a product to a power. We have a product to a power. Each factor of that product. 16 is a factor. M to the 8 is a factor. We give each factor its own exponent of 1/4. And then, Noah?
Then we would change m to the power of 8 so it would be 8 over 1 and 1 to the 4.
Okay, so this is going to become m raised to the 8 over 1 times 1 over 4 power.
And then that would be 8 over 4,
And that would be m to the 8 over 4 power,
which would equal m to the second power.
which would equal m to the second power. Okay. I'm kind of ignoring that 16 for a while, and we don't like it. Okay. So we got that part. We got the m to the 8 raised to the 1/4 power. We got that figured out that it's m to the second power. What are we going to do with that 16 to the 1/4 power?
16 to the square root of 4.
Okay, the fourth root, here's how you say that. The fourth root of 16, that's how, so you know, because typically we would say the square root, wouldn't we? But it's not the square root, it's the fourth root. So we say the fourth root of 16, and then the fourth root of 16 is, that means what times itself?
4 times.
4 times gives you 16, and that's 2. And so we have 2 times m squared, and that is
2m to the second power.
2m to the second power. Okay, so now let's check to see, could we use the newfound property that we just talked about? Can we do what we were doing? Can we take 16 now and divide it by 4?
No, because that's an 8.
Because that's what? That's 4. And did we get 4? No. So caution. Be careful. If you want to use a shortcut property, it better work all the time, right? Does it work for the variable part? Let's see if it works for that part. We have the m to the 8, so 8 divided by 4 is 2. And did we get a 2 on our m? Yeah. So it works for the variable part, but it did not work for the constant part, did it? So we can
That's when you
only,
literally have to find the square root.
that's when you literally have to find out the root, whether it's square root, cube root, fourth root, fifth root, whatever it is. So we can't use our shortcut for constants, but we could, looks like we can use them for variables, right? Okay, so, anybody have any unanswered questions? Okay, then let's get started on your homework. Or at least get your heading down. I'm going to give you your grade sheets next.